This is Shinya Sakuda, Solution Architect with Rolta AdvizeX. And today we'll be talking about VMware NSX and talking about VMware and AdvizeX and how we can transform the data center network. So we'll go over the overview of NSX, and then later we'll talk about how we can help you. And we'll take the time to do questions all the way at the end, and we're recording this session. So if you have questions, please type them in the chat window, and we'll go over the questions at the very end of the session. So going beyond server virtualization, every industry is being transformed, and most of you probably use Uber, Netflix, Airbnb maybe, and other disruptive technologies. These disruptive business models powered by innovation, new thinking, and new approaches. Is innovation, new thinking, and a new approach transforming your industry, or is it about to? The business leaders seeing that the speed and agility that they expect from the IT is possible, but many IT organizations are constrained by legacy architecture and operational practices, which makes it difficult to meet those expectations. So it's time for a new IT approach. It's time to virtualize the data center, taking virtualization beyond just the servers. It's now possible to bring the operational model of a VM to the entire data center. A software-defined data center approach allows IT to achieve the agility and the speed to programmatically deliver an entire application stack in minutes instead of weeks, and efficiency to reduce cost and automate on-the-fly changes without any human intervention, and security baked into the platform, making a data center more secure than it has ever been possible. So let's take a step back for a moment and look at how traditional enterprise data centers are built and managed. The enterprise applications rely on services provided by the physical infrastructure to provide the security, load balancing, routing, and service chaining, etc. All services that the applications are tied to and often require significant manual configuration and management. This approach was fine when they were originally designed in an era of static physical servers and client-server traffic patterns. But if we look at how the most efficient, most agile giant data centers in the world have done it, it's very different. Many of the services that have been traditionally delivered by physical network devices have been moved into software stack and have been distributed out to the applications. This gives these giants speed and agility and allows them to simplify the underlying physical infrastructure and increasing the stability and the reliability and reducing costs at the same time. But let me make it clear that most of your data centers do not operate and cannot operate the same way that the Google and Facebook and Amazon do, and have no plans to rewrite your applications and implement the distributed microservices architecture. So we're delivering the ability for enterprise data centers to achieve the same kind of speed, agility, and efficiencies as Amazon, but without rewriting your applications. We have moved intelligence that has traditionally been delivered by hardware into the data center virtualization layer in the software. So by moving network and security services into the data center virtualization layer, the data center operators are able to achieve the operational model of a VM for the entire data center. And now it is possible to programmatically create, snapshot, store, move, and delete, and even restore entire application environments with the same point-and-click simplicity and a speed that we spin up a virtual machine. But I feel like most customers that I talk to, You're saying to yourself, well, what does it even mean for my environment? And no enterprise data centers wants to do a complete rip and replace forklift upgrade, as it's a massive change in operations. And that is the beauty of the network virtualization and a software-defined data center approach. We leverage your existing infrastructure investment, add a software layer, which allows you to do things and solve problems which were simply not solvable using the traditional approach. The network virtualization begins with the infrastructure you're already familiar with, your physical network, servers, and storage. A common misunderstanding is that the network needs to change, but in most cases, it doesn't have to change at all. I assume that most of you are likely running vSphere for your server virtualization layer. And as you see during my presentation, this is where we're able to distribute network and security services out to the applications to create what you can think of as a network hypervisor, which, like a server hypervisor, allows you to programmatically create, snapshot, move, delete, and restore software containers and virtual machines that represent the x86 construct applications. And we can now programmatically create, snapshot, move, delete, and restore entire data centers as software containers to deliver flexibility, agility, security that were never possible before. So we do this by distributing network services into the hypervisor, where they can be provisioned with the application workloads and take advantage of the application context because they are operating right at the application's interface to the data center construct. By doing this, we can take advantage of distributed performance. Network traffic no longer has to be sent to a choke point firewall device because security controls can be enforced at the virtual interface. Assuming that your hypervisor have two 10-gig network cards, each hypervisor can theoretically deliver 20 gigabit of firewall capacity. So as you scale out your application environment, you are scaling out your security capacity without adding any additional firewall hardware. The result is aggregated distributed capacity with centralized management and control. And that was not possible with hardware or traditional operational approaches. I'm sure you have heard of the term microsegmentation by now, but it is important to understand the challenge microsegmentation solves. Because the problem isn't something new. It just was not feasible to solve until now. If we look at all the well-publicized attacks over the last few years, like Target, Home Depot, and Sony, and others, they all were different from a hacker code perspective, but they all had one thing in common. Once the threat got through the perimeter defense, whether through the firewall or from the inside, there was little or no lateral controls to keep the threat from moving from server to server until it found what it was looking for and started pumping out credit card information or other private information. Nirvana to most security teams is microsegmentation or zero trust approach. However, even if your company can afford the capital expense for enough firewalls to deliver the throughput capacity required to achieve microsegmentation in your data center, the operational complexity of managing changes and VM movements will make this approach operationally infeasible. It's easy to understand why traditional approaches are operationally infeasible. When the packet leaves the VM, they must traverse the network to be evaluated and enforced at a choke point firewall. And that means that when the VM was provisioned, someone had to write the rules and put them into the firewall, a time-consuming, error-prone process that slows down application provisioning. Then if the VM ever moves, the firewall likely needs to be manually updated. And if the VM is deleted, the firewall should be manually updated or remove the rules for the deleted VM. All combined to make this operationally infeasible at scale. So how does an SDDC approach make it feasible? It's because we automate everything. When a VM is provisioned, its security policies are provisioned with it, so that when the packet leaves the VM, it is evaluated and enforced right at the virtual interface. And if the VM ever moves, the rules move with it. And if the VM is ever deleted, the rules are deleted with it. And there's no human interaction. It's all automated. Probably most significantly is that we make this security policy machine readable. For most data centers, the security policy is a human readable document that is created by a policy team, a security team, and implemented by the network or firewall team during the provisioning process. Someone looks at what kind of workload it is and what data it has access to, then finds a policy out of the documents that manually creates those rules that is supposed to enforce the intended policy. But NSX changes all this, making it possible for the policy to be written as a machine-readable document, so that before the time of provisioning, a policy that describes a different kind of workloads and data has all the rules already defined. And then when I select the production workload on a database tier with customer and PCI data, the rules that will enforce the policy have already been created. The automated provisioning process simply gets the IP address and builds all these rule sets in seconds. And that rule is then enforced at the virtual interface. The allows and denies and all redirects are all logged into the standard log file. And that log file can be consumed by existing auditing tools, and the whole process can be easily auditable. It is important to understand we're not talking about replacing the north-south firewall. You will likely leverage hardware-based firewall for its performance and throughput capacity for a very long time at the perimeter of the data center. However, it's important to understand that there's a big difference between physical or virtual firewalls or distributed firewalls. The hardware-based firewalls, like I said, are designed to deliver high performance, high capacity throughput, most of them between 30 to 120 gigabit per second. And also the virtual firewall, and every hardware firewall company has a virtual version, but the throughput dropped from 100 gigabit to 1 gigabit or so. And you don't really change the operational model of the firewalling at all. What we are talking about is the distributed firewalling, where the security layer is baked into the infrastructure itself, not bolted on. The distributed combines an automated operational model and scale out throughput performance. Using a software-defined data center approach, firewalling policies are provisioned with and enforced at each VM's virtual interface. The firewalling function is done in a hypervisor kernel and delivers on the order of 20 gigabit per second per hypervisor. So as you scale out your application capacity, you are scaling out your security capacity at the same time. And I always get the questions on, well, how this affects the hypervisor performance. So here's the data. The darker blue on the left shows the performance of forwarding packets without filtering, meaning no distributed firewalls, and running at about 20 gig per second. And lighter blue bar on the right shows the performance of forwarding packets while filtering, meaning using a distributed firewall. And it runs at about 19.7 gigabit per second. So very little impacts to the hypervisor ability to forward packets because we're doing the filtering in the kernel itself. And we get about 80,000 connections per second compared to a typical virtual appliance firewall, getting about 6,000 connections per second. And again, this is 80,000 connections per second per hypervisor. And this is only applied to the VMs running on that particular hypervisor. So as you add a host, you're adding 80 more thousand connections per second capacity. So it's this combination of hypervisor-based in-kernel distributed firewalling and platform-based automation that is making a data center microsegmentation a reality for security teams today. It is also important to align the type of controls to what you're really protecting. So isolation, where there's no communication path, maybe for separate tenants, separate dev, test, and production environments. Another is explicit allows. This is your standard stateful firewalling. And it controls and filters on source and destination, addresses and ports and protocols. And this alone can dramatically reduce the risk profile of your data center. As you know, what this app server talks to, this database server on what port and protocol, and you block any other ports and communication between those servers, you'll eliminate the ability for threats to propagate laterally. And finally, the advanced security controls. NSX works for the VMware partner like Palo Alto Networks, Intel Security, Trend Micro, and Checkpoint to deliver advanced next-generation firewall inspection and IPS by allowing them to integrate with the NSX platform and leverage the distribution and automation delivered by the platform while utilizing the product to deliver the advanced feature sets. All in the service chain at the virtual interface and based on a common policy. Let's quickly look at how this advanced insertion works using Palo Alto Networks as an example. So Panorama, the Palo Alto Network Management Console, registers with the NSX controller. And the controllers have then distributes the Palo Alto Networks, the VM series application, which are virtual appliances, to each hypervisor. And you create the security policies with a Panorama, then apply them to the VMs as well as physical resources. The NSX firewalling steers the traffic into the Palo Alto Networks virtual appliance for the packet to be inspected. And if the VM moves, the NSX platform automates the move in the security policies with it. And this can even occur in the mid-session. And because NSX operates in the hypervisor and understands the workload's context, we're able to define groups based on things like operating system or workload types, such as web, app, and database servers, and et cetera, and et cetera. The result is the ability to create isolated application environments with stateful firewalling controls down to every virtual interface, and advanced controls where needed, like Palo Alto, and ability to place them and move these workloads anywhere in the data center and even across the data center. You might have a web tier workload and a database tier workload on the same hypervisor, but not even able to talk with each other, and have an application tier of that environment in another part of the data center, but operating like it is clustered with the rest of the application environment. And if anything moves, again, nothing changes because all networking and security moves with the workload. It's all automated. So now we know how awesome NSX is. Let me talk about how Rolta AdvizeX can help you. We're proud to have earned some of the industry's highest accolades, including 2014 Software Defined Data Center Partner of the Year and 2016 Global Professional Service Partner of the Year from VMware. Rolta AdvizeX is one of the few elite NSX partners in the world currently. We have multiple VCDX MV on staff, which is the highest achievable certification by VMware for NSX, and certified implementation engineers in every region. The AdvizeX enables IT departments to focus on what's really important, driving innovation and revenue in their businesses by providing services across the entire business solution lifecycle, from planning through building and managing the solution. Our planning services help IT and business team align their goals and identify those solutions that will have the greatest impact on their bottom line. We offer NSX-specific assessment services and planning and designing services using our proven method. And all of the planning services, as well as assessment services, are listed here. And AdvizeX has some of the most experienced and knowledgeable engineers in industry to help our customers build solutions that really work. We're constantly updating our skill sets and partnering with technology leaders to ensure that we can deploy best-of-breed, state-of-the-art solution faster and better than anyone else. We can help you pilot NSX, help you deploy the solution, as well as do advanced consulting to help you with integration and perform automation with other tools you may have. And AdvizeX is different than most IT partners because we can continue to deliver value to our customers across the entire solution lifecycle through our global managed service. We're there for you for the life of your solution with remote support, troubleshooting, day-to-day operations, maintenance, upgrades, and more. AdvizeX can offer a variety of managed service customized to your needs after the implementation to help you operationalize the NSX. So what is the next step? So you can get started with one of our advisory assessments to assess your technology needs and measure your IT strengths and weaknesses against relevant industry benchmarks. Or you can engage us for a complete and complimentary on-site technology review with your IT team. And you can be our guest at one of our executive briefing centers for an executive team meeting and an opportunity to see our solution firsthand. We're also currently offering a free NSX assessment using Virtualize Network Insight. This assessment will analyze your network for the east-west traffic and help you understand what benefit you can achieve from NSX. And this is absolutely complimentary. So please contact your account executives if you're interested in this assessment or any of the other services I have mentioned. Now I'd like to open the floor for questions. So if you have any questions, if you could type to the chat window, I can answer to any of them. Anybody with the questions? Looks like there's no question. So thank you for your time, and enjoy your lunch. And appreciate you taking the time to listen to this webinar. Thank you very much.